Hello and welcome to the first LEGO League Challenge Robotics Robot Design Summary video. Um, my name is Stan Weeks and I am a former uh, first LEGO League Challenge mentor and coach for the SWATbots Team 1746. Um, we are no longer a first LEGO League team due to our team members aging out and moving on to FRC and so forth. But um, my job, or I was asked to help the coaches this year and in the future to take a look at how to prepare teams. The the rubrics have changed this year as well as judging for this upcoming season and replay. And what we're going to do is take a look and see how we can make and help your team be best prepared for the judging of the robot session. So, just real quick, what I want to start off and look at is the judging flow chart and what's going to happen. Okay, teams are going to come in. And again, there's going to be a welcome, and team sets up materials and get everything ready. They're going to talk about the innovation project for 5 minutes. Then they're going to have a question and answer about the innovation project. Okay. Then they're going to go into robot design explanation. So this is what I'm going to talk about. I will say that your team needs to have something prepared for this. So in the past, there's been a table in the room that the teams would be able to run the robot on. That's not happening. Um, this is more about showing preparation and documentation and the almost like the engineering process. If you're familiar with what's called Project Lead the Way, of hey, this is what we've done. Here's our documentation of our steps of building, our steps of programming, our and our trial and errors. We've tried this, it worked this many times, it didn't work this. We tried this piece, that didn't work, so we went to this piece. So looking at that process and how we can prepare your team to speak with the judges and get ready. Then the judges will have a 5-minute time to question and answer over the robot design. And then there will be a reflection for 3 minutes of core values, and then feedback. The judges will provide feedback for 5 minutes. So looking at that, let's look at the robot design. Let's look at the robot design rubric. Okay. Now your teams have to be ready. Okay, meaning that they need to understand the rubric. This should not be unfamiliar to them. How I always prepared my teams or my team, and I was a coach of other teams before as well, was I would show them the rubric because these students are familiar with rubrics in their educational life. So I would show them the rubric and I'd be like, okay, let's go over the rubric a little bit and let's talk about the rubric. What are they looking for? Okay, so the first tab here is identify. Identify that the team had a clear, defined mission strategy and explored building and coding skills they needed. Okay, so we need to make sure that as judges, we can see that inside of their engineering notebook. Okay, so inside their engineering notebook, it's got a lot of really good stuff here about, hey, this is what we need to do. Okay, um, in regards to the robot build process or programming process. Here again, they're talking about a Spark, which again you can use an EV3, but they talk about missions, um, and then in session one. Okay, so and again, if you've met before, that's okay, but what you need to do is look over this and say, okay, what have we done? Um, you know, what did we talk about today in practice? So my teams, we created a journal, which was very similar to what they're trying to do here in the robot design uh, uh, book. Okay, inside of this, um, uh, you know, notebook. So what we did is we created a notebook or a book of our own, and we documented what we did each practice, what we did in robot design. These students or these team members worked on programming. In the programming, this is what we did. We worked on this specific mission. Um, we tried multiple different things on this mission to be successful. So, and they would talk about what they did, maybe what they had to change. The robot, we couldn't get the turn correct, so we had to go out and do some research on um, how to get the robot to turn more accurately. We went and referenced and watched some YouTube videos from other teams from around the world. Okay. We looked at the um, we looked at the active, the lessons, the robot lessons, to try to figure out how to move or turn using maybe like a curved move or something like that. Okay, so we want to see evidence of this documentation, and we want to see evidence of this team member, these teams have, they started here not knowing hardly anything how to get the robot to move out, but over time they have grown, and maybe they went from learning how to turn the robot on to in practice 1 to in practice 2 they have the robot driving out of the base. Okay. And then in practice 3, we drove out of the base and we turned and we went to this model. Okay. So those documentation steps is what we're looking for based on this new rubric. Okay. What we also want to look at is, especially in this very first one, is it says fully clear mission strategy. So, and again, we're wanting to go for a 3 and a 4 even, okay, is where you're looking at, winning those awards and truly stepping up as those teams. So full clear mission strategy. Why did you choose those missions? Did you just choose them because they were cool? If so, that's great, good job. But now, how did you plan on tackling those missions in that order, and why? Why are you going there? Okay. One of the things that my team always did is we looked at what missions, and we would talk with the group and we would go over the missions. So we would sit down and we would go over, all of the missions. We would look at all the missions. We'd look at all the points on the board, and we'd say, okay, what do we want to do? What mission do you want to tackle? Why do you want to do this mission? And then we would talk about, all right, so once we've looked at this mission, why is it important to tackle that mission or go after that mission? What's important about it? So, and sorry, this is what I was looking for, the robot path. So what you might want to do is have this path, um, and you can go out and say, all right, so we as a team liked these, let's say 5 missions. Okay. And looking at these missions, why did we go after these 5 missions? Well, we thought they would be easy to obtain. Okay. So easy to obtain means that maybe they're close to base. Or if you're a more advanced team, maybe you can string 2 or 3 missions together based on lines on the board and backing your robot up against the walls, or, you know, doing something like that. How did you string missions together? And why did you try to group those together? Okay. So that might fall into that 4. Okay. You know, these are the missions that we wanted to go after. And this is why we wanted to go after them. And this is how we decided to go after them. Okay. So you want to make sure also all the team members are included. Okay. Everyone on the team wants to work on the robot. All right. And you'll always come across those alphas on your team that try to push everyone else away from the robot so they can do it. You'll also have alphas on the project that push everyone else away from the project so they can do it. So you got to make sure that to be a well-rounded team, everyone has to have some sort of input or learning on the robot, and they've got to have some sort of maybe mission that's their own, or you know, hey, this is something that I helped design, and you know, I helped design this piece of the robot that would complete this mission. Okay. And if everyone has a little piece and can own that, then they're going to show that in the judging room. All right. So that's what identify would be after. Okay. That's what we're looking for there. Okay. Now, design. All right. The product, the produced innovative design and a clear work plan, seeking guidance as needed. Okay. So how do they work through this? How did they decide to build the robot? Did they go with just a kit bot, which is absolutely fine? Working with a kit bot, there's nothing wrong with it. Using a basic kit design and then building from that and making attachments that'll work on that kit bot. There's nothing wrong with that. I've seen some great kit bots in my judging that outperform some of the big boxy robots. Because the programming was good, the attachments were able to go on and off of the robot very quickly, and they worked. Okay, so what we're looking for here is a lot of evidence of an effective work plan. So they started here. Okay, I built this piece, it didn't quite work, so we moved to this piece. Maybe iterations of, you know, the design process. You know, we started here, this didn't work. Taking pictures and showing, you know, this is how we moved through our build process. This is how we moved through our programming process. This is how we moved through, you know, we tried this mission with this mission. They didn't work. The wrong type of attachments. We couldn't get this to work, so we had to maybe adjust this attachment a little bit. Okay. So a lot of explanation of robot and codes, innovative feature. So one of the things that we did a lot of was we put comment boxes above our coding. So my team would have a comment box, and it would go above the the line of code, and that would, you know, tell the judge, hey, this is exactly what this box of code does. And we did that so our judges would be able to, you know, look at the code and be able to easily read it. Because as a programmer, you know, you can write code all day long and people don't understand it. You need to have comments and explanations of what that does so people can basically know what you're trying to do. Okay. So create, team developed an effective robot and code solution matching their mission strategy. Okay. So the robot that you're building, okay, it's going to work with what you've decided to set out and do. So maybe you decide to set out and and drive out, do a mission, and come back. That's absolutely fine. But in that aspect, you need to have maybe a part of that robot that can do more than one thing, so you don't have to be changing your attachments all the time. So maybe you have an attachment that handles or can do 2 or 3 missions, and you leave that on that robot every time. It drives out, it does something, it comes back, and all you have to do is pick that robot up and move it to its next starting point and then run the next program. It goes out, it does something, and it comes back. Okay. And then you pick that robot up and move it to its third starting point, and then it goes out and it does its thing, and then it comes back. Okay. Now I talk about starting points. One of the things that you want to get your team used to doing is either starting from the same point every time, or having something created to where they know where they're starting off on their mat every single time. So maybe it's a jig of some type that they can set down. They line the robot up and they move that jig away from that robot before they start. Okay. Or maybe it's a it's a location or a jig that sets there, and then they move it every time, and they start from the exact same spot every time. Okay. And having that strategy of, always knowing where to go, and then that way the team has that consistency and understands that, hey, this works really well. Okay. Iterate. So team repeatedly tested their robot and code to identify areas for improvement and incorporated the findings into their current solution. So again, looking at this high accomplished, need to be tracking how many times you run your robot. Did it work? How many times did it fail? How many times did it work properly? Because these are Legos. They're not going to perform the same every single time. But you want to get your robot performing on your table constantly. Now, when you get to competition, it's not going to work. My team could get a robot to work probably 80 to 90% of the time at the house. And then when we went to competition, it would work maybe 50% of the time. But they have to be okay with that, and they have to be able to show the evidence that, yes, we've ran this program 60 times, and it worked 50 out of the 60 times at our home. Here's our evidence, and like a data chart, okay? And then when they change something, they would write maybe in their data chart, change this in the code, okay? So evidence of where they changed their code to make sure it worked right. Or maybe they had to change a starting point, or they changed their starting block, okay? Or maybe they were finding out that a team member was setting the starting block up just a little bit different, so they had to tweak that, okay? And then communicate. Explanation of the robot's design process was effective and showed how all team members have been involved. Again, all team members, okay? You're gonna have students that want to dominate or take control over that robot build. This is my robot. It's the team's robot, okay? So you wanna be able to show that all the team members had involvement inside of that. And that, a lot of that goes with just having all the team members work on all aspects. And I know sometimes that's difficult because some of the team members don't want to work on the project, or they don't want to work on the robot. On my team, I had a gentleman and a young lady that didn't want to work on the robot. They liked working on core values in the project. And then I also had other individuals that didn't want to work on the project. They wanted to work on the robot. Okay, so spreading that out and making a well-rounded team to where they all can speak to this. So one of the things that we tried to do inside of our 5 minutes that we used to have was we would go through and be like, okay, how can we talk to the judges and show a 4 on identify, and show a 4 on design, and show a 4 on creativity, and show a 4 on iterate, and show a 4 on communicate. Now, how can we do this as a team? And we sat down and we would write out almost like a script or a little skit for the robot design. And our presentation would be that of the robot design. So what I'm going to do here is pull up some of the items that we used as a team, and show some examples of what we did, and some books that we created, and some of the other things like that. Here we go. Looking at this, I'm going to just go into the robot design. If you notice, we created a Gmail for our team, and this is how we would communicate with people for project and stuff like that. We would send it from our robot Gmail. Okay, you're going to look here. We had book covers because we had a book for every aspect. So project, core values, and robot design. Now this was under the old format where we actually went into 3 separate rooms. Okay, so but what we would do in this case is we would have a project book and we'd have a robot design book. We wouldn't have a core values book because of the way that judging has changed a little bit. But I mean, it's still good to possibly, have a documentation of, hey, this is what our team has done this year, and this is how its core values, and this is how we get along. This is what we've done. Okay. But looking at the robot design part, okay, so I'm going to go in here and I go into robot design, and there's nothing there, of course, because I've moved the stuff. And I think City Shaper was the last robot design. So if we go into robot design here, okay, you're going to notice that I've got pictures inside of here that the team has taken. Here was our starting jig. Okay, so our robot started at the same place every time. Here was a picture of different attachments that we used. Okay, here was here was a part of, hey, these are the missions that we're attacking. Our mission number 1 was the crane. And what we did, what other items we did during this. So we basically broke it down and talked about, hey, this is our missions. This is what we did. Mission 2, our swing. This is what we tried to accomplish. These are the things that we did. Mission 3, mission 4, and then we had a breakdown at the bottom. Okay, so we kind of gave the judges a, hey, here's what we did. So when we were talking about, our missions, maybe somebody was showing the judges the book, or you would reference the page of your book that would say, hey, this is, if you turn to this page and have them, tabbed out to where your team could reference them. Okay. Part of our code. Okay. This is just a picture of our code. Okay. So we used what's called My Blocks, and we created a My Block for driving and for turning, because those were the 2 main things that your robot would do, was drive straight and turn. Okay. So we went out and created a My Block, and those My Blocks would then be used over and over and over again. So reusable code. And this would tell exactly what this block would do, where it was going, what it was doing. Okay. It would also give the name of the programmers of that. And then the pseudocode is, hey, what do we want this thing to do? We want it to drive out of the base. Now, a lot of this stuff that I'm talking about that we put in our book is actually can be put inside your engineering notebook. And that's what's really cool, because the kids can cut out and paste these pages in and write into it and stuff like that, to where what we had to do is we basically created this on our own. Okay. And then there's different programs here, we had a swing program, a red, a ramp. So we named all of our programs. Okay. Then we have here, this is what our robot book looked like. And again, this is where your the engineering notebook comes into play, because it's almost the exact same thing. Okay, so all of our current attachments. All right, so we had you know, 1, 2, 3. We had 4 attachments for this robot that completed all those missions. Okay, this was our starting block. So we started from the exact same space. Okay, here's our mission crane, our swing attachment, and other attachments that we used. Okay, we used one attachment for 3 different missions. Okay, and then our ramp missions. Here was a picture of our robot. Okay, so what we did is we didn't show our iterations of this inside of this, but let's say we changed this attachment. What you should do in the new rules is, or not new rules, but in the new judging ways, is to show, hey, how did this change? What did we change? What did we add? Okay. And then here's a breakdown of the missions. And again, this is going back to that engineering notebook, your robot path diagram. What we did is we looked at, all right, so our robot's gonna drive out 1, back up, and go back into base, or go back to home, or whatever. Okay. Here was our second mission, going out, breaking it down step by step, showing exactly what this thing's doing. Okay, going through and talking, basically showing the judges exactly how I'm planning this out and how we designed this to work. Okay, and you can also put in here, hey, we had to try this mission multiple times. All right, now you know, some of you new coaches are looking at this going, oh my gosh, how many missions do they run and how can we get to this? This is a product of a team that had been around for 4 or 5 years. Okay, and team members that started in like 3rd grade and kindergarten and 3rd grade, and have been around team members that had aged out. So they watched the iteration and how these team members did this. It wasn't program the robot to come out and turn, and then each one of these was a program every single spot. So number 1, we would program number 1, and we would run that number 1 like 5 times until it was perfect every time. Then we would turn and drive number 2. So we would get to where we were consistently hitting the same spot in the board every time. Then we would go do number 3 consistently every time, number 4. So it was 1 step at a time, getting each step. Okay. And then here's our number 3, our 4th mission, and our 5th mission. This right here, this mission alone took our programmers, and as simple as it is, it took our programmers about 4 hours to program it and to make it perfect. And what I mean by perfect is that this robot in this season would stop and hit both of those flags every single time. And we were very consistent with that. But it was all about using the lines and getting the turn right. But it took them about 4 hours to program something like this. Okay. And that's okay. If you, this program, I can't even tell you how long it took those kids. But this is a very high level, multiple mission program. And your team might not do that. They might just come out and do one thing and then come back, and that's okay. If they're doing it consistently and getting those points, that's what matters. And that's what we're looking at is, all right, so how did you tackle that? Okay, so that's City Shaper. Okay, so going back and looking at, let's go back to hydrodynamics, or actually let's go back to Into Orbit, which I believe was 2 years ago. Okay, looking at their robot, how has this changed? Okay, so here looking at the robot book for this. If you notice, that robot looks very similar, doesn't it? Because my team used it in this season and decided to use it the next season. Here were the attachments for that. Okay, now, if you look, this team did a better job of documenting the iterations of the arm. This was their first version. This is their second version of the arm. This is what we went with because it was more consistent. Okay, they talk about, we use this arm in 2 of the programs to help in 2 different missions. Okay, version 1 of the arm. Okay, why we changed that. Okay, so they didn't really change this arm that much that I remember. Again, I was just there, and they were the ones changing stuff. Now here we had version 1. Here version 2 is much different. Here's version 3. How they changed it, why they changed it. Okay, and then here's version 1, version 2. Looking at these different versions. Okay, version 3, version 4 of this. So looking at these different items and how the teams walked through, even my teams even had tried to go with the CubeBot, okay, and opted to go with, this is a base robot that's just turned around backwards, okay? So instead of the ball, they use this large wheel in the back and they turn the robot around. So this is this is similar to a very base robot that you can build using the Lego instructions that they use and were very successful with. So what they also created and what we used to create was a robot board, and we would talk about different things in that robot board. The rubrics again have changed. So again, you want to create something that goes through the rubric and speaks to those points, and you have to be able to do it in under that 5 minutes. Okay. Now, last one is hydrodynamics, and I'll show you that. Again, go into the robot. Okay. Again, evolution of this. This was 3 years ago. So as you can see, the version before this was the year after. So this is just screenshots. Okay. They didn't have much documented on their robot here. Okay. Now, what they did have was a lot of experiment pictures and stuff like that for their project, but they didn't spend as much time as they did in Into Orbit and City Shaper on their documentation process, but they learned that from their rubrics. Okay. So this was 3 years ago, this was 2 years ago, and this was last year, I believe. I think City Shaper was last year. But this was the last year that I coached, this was the year before the last year, and this was 2 years before that. So it's an evolution process, okay? Your team will not be perfect their first year. They're gonna have hiccups, but they need to show that growth. And showing that growth from first practice till when they come into the judging rooms is what it's about. So I've given you a lot of information. The key that I want you all to follow is look at the rubrics, sit down with your team and talk about the rubrics, about, okay, how can we get everyone involved? How can we show a mission strategy? Why do we want to attack these missions? Okay, you got to show the why. All right, why are we doing this? And if you can come away with that, then your team will be very successful. Come up with I just call it a script because it's talking points that each team member can talk about in each, maybe one of these areas. This is what we did as a team. This is what we did. This is why we chose this mission. You know, this is why we chose this design. This is why we chose to create these attachments. This is why we decided to use these sensors. Using sensors will be a big thing in your programming. If you can use a gyro sensor, maybe use a color sensor to stop on a line, and stuff like that. Those types of things will help. So if you're looking at, and this can all be found on the First LEGO League website, the alternative robot lessons, okay? So if you can go down here, here they're talking about sensor blocks, okay? They're talking about beyond basics. They're talking about stop at a line, okay? If you can have your team members learning some of this programming languages or programming knowledges, then what will happen is they're going to be able to navigate this board a lot better than just kind of going out with no sensors and hoping that it's at the right place. Okay, so if you can utilize some of those sensors, that will be helpful. Now, if you have questions or comments, then you can reach out. The team's email, which we still have active, and I'm going to highlight right here, is swatbots17486@gmail.com. My daughter will, she's created some videos that are on a YouTube page, and I can pull that page up real quick and show you. My son's also created some videos for that page. Now, these are older videos back when they were on the team, but they talk about, how to, program certain things. So let me just go to YouTube real quick, and let's find the SWATBots channel, SWATBots 17486. So I just go to Google, SWATBots 1746. Here is their page. So if you click on their page, it goes through, and that was my City Shaper team right there. They've got different runs here, and if you actually go through all of their videos, they've got a My Block building that talks about how to do My Blocks. They show you some of their skits, some of the other things that they have done in the past. So if you click on videos, you can see, some of this was, back when Core Values was a separate judge thing. So you can see the iterations of what this team has kind of gone through, and, how to program My Blocks. And there's some other programming. I think they've got maybe another programming thing out there that they talk about, but they have some videos that they show out there of how their robot runs. So just some of those things. So feel free to email us at swatbots17486@gmail.com. Again, I'll highlight this so you can see that. And if you have any questions, just let us know. Thanks.